Good. Okay. So we're going to do string methods today, but before that, a little bit of housekeeping. So this is my last lecture with you guys. For Castro is going to come in. He's going to do the object-oriented programming module with you, I think for 4 or 5 weeks. It's not the last you're going to see me. I'm going to be in for the penultimate and ultimate lectures on recursion, functional programming, and complexity theory, which are very interesting topics. Complexity theory, especially, that's sort of getting into proper computer science. There's an assessment deployed. Are you aware of this? I need you to at least download and read the spec. We've only had 90 submissions made to the grade scope. That's not enough. This is going to be more sophisticated than you may realize, so start working on it. The reason that we've given you 4 weeks to work on it is because it takes 4 weeks. This is not something that you're going to do 2 days before. It will be impossible. It's like trying to learn piano before your recital. It's not going to work, right? So I'm pleading with everyone. Please get on top of this. Not this Saturday, but the Saturday after, you're going to be having your midterm. If you know how to program in Python, the midterm is going to be fine. Right, that's all we're going to be testing on you guys. How to write Python code, how to read Python code. There's a sample, and I think at least 2 previous years on the blackboard. We don't provide solutions, not because I'm trying to be mean, but because we found that when we release solutions, exam outcomes are quite poor because people just look at the solution and say, I'd be able to do that. I'm like, I'm not sure. So that being said, if you want any of your solutions to be validated, just put them on the EdStem and we'll tell you that it's right or that it's wrong. So we're quite happy to have you guys produce the solutions and validate that. Is there anything else I'm forgetting? Okay, I'd like to give away more ducks today. I have a bag. I got a lot more stickers. So let's try some course engagement. And then we've also produced, this all kind of started as a joke, but now we have merch. So if you guys are like interested in, so you can have one of these for $30. I'm going to post something on the EdStem, organize an order. We've actually have mascots now for various courses. Some of you may know about the bears in Comp 3400. That's sort of the genesis of all of this. But if you guys want sort of like a little bit of a memorabilia piece for your time with us, shirts are available. So I'll just post something to the EdStem about that. If you guys want some, I'm happy to organize an order of that. Yeah, they're all pretty cool. Do you want to see some of the other logos? Yeah. Okay, I'll show you some of the other logos. That's for the Learning Center. The mascot was a turtle duck. Don't ask me how that got started. This is the one for my 3400 class, for which, yeah, bears are a big thing there. Comp 3301 is the blowfish. OpenBSD has a mascot pre-existing. That's the blowfish. So for those of you going to operating systems and architecture, that will be the mascot. This is Java Duke. He's the pre-existing mascot for Java. You'll be learning this in CS 2002. This is a bush turkey. This is what Joel chose for algorithms and data structures. You can see there's a binary tree type of flourish in the wing, which is an important structure. And bonus, this is my son who loves Hot Wheels Let's Race. So I'm going to print one for him because he always runs around the house going, speed mode activate. So shirts are available. That's the point here. Okay, so what are we going to do today? So what we need to do is we're going to now deal with file processing. So I'm not really going to be introducing any new control structures. Well, that's not entirely true because we're going to be introducing with. But what I want to do today is just talk about, reading to files, writing to files, and in particular, working with strings. Right? Because the only things that are in files are strings. Even if there are numbers in those files, they're strings. Anything that you take from input from the user is going to be a string. And now we're going to abstract that away. The input doesn't necessarily have to come from a user. The input can come from any sort of text stream, typically that of a file. And because we're going to be working with strings, I just want to tell you about string methods because a lot of things that you want to do with strings, the functionality for doing that is already pre-built in. Now, I want to caution you, there's like hundreds of string methods in here. And furthermore, on your exam and on your midterm, we may say things like you're barred from using string methods, right? Because we need to be able to ask you guys easy questions. And if the answer to that question is you just using a string method, that sort of trivializes it too much. So whenever you use a string method, I want you to implement it once yourself. And if you can implement it once yourself, then at that point you can abstract that away and use use the string method. So we'll just go ahead and get to it. So last lecture with me. Oh, this has to be updated because last year we lost a lecture due to the, what did we lose it? I've lost lectures to COVID and flooding and hurricane. That was a hurricane, right? That we last term that we had. No, I think Alfred, right? Okay. Anyway, we lost the lecture last year to a hurricane, so I had to remove a lecture. The intersem is not this Saturday, but the Saturday after. It's geez, and that's something else. That's the ice hockey. That's no longer in the first term. I say everyone gets a 7 if the Maple Leafs win the Stanley Cup, which will never happen because they're cursed. In any case, okay. So we want to talk about files. So during file processing, we're working with strings, and because we're working with strings, we're going to be utilizing the string methods. But I just want to caution you to implement them yourself before utilizing them, because on an exam I can easily say something like implement this string method. So strive to implement any of the things that you see or use at least once. Okay, so built-in string methods. So eventually you're going to learn about objects, and you're going to learn that objects have something called the method. Right? I don't want to blow the lead, so I'm going to let Casper talk about that. But today we're effectively doing object-oriented programming on the object, the specific object, the string. If you type into your REPL help on string, you're going to get basically you're going to see hundreds of these sort of string methods. So if I go in here, oops, I'm just going to go into Python. So let me get rid of that. Move this over a bit. I can say help on string, and you're going to get a lot of information. Right? Oh, go faster. So all of these are string methods, like this end with, find, format, index. There's literally hundreds of them. So if you want to see help, just type help on string, and you'll see them. For example, there is a method called capitalize, which returns the capitalized version of a string. That's quite useful. There's a method called casefold, which returns a version of the string suitable for caseless comparison, right? Sometimes you want to say, are these two strings equal, ignoring the fact that some of the letters are capitalized or not. So we'll eventually learn that strings are objects, and objects have a different invocation method than we're used to in imperative programming. So in imperative programming, we have functions, and those functions take things. In object-oriented programming, it's a little bit different, right? So this would be the imperative style, right? So we're used to having a function which we give an argument. That's not how a method is called. A method is called a little bit differently. A method is called like this. Hello is a string, and it has a method that we can invoke by using dot, and then using the method name. And then these closing braces are important, right? Because this is performing an imperative, some action, that's what those empty braces denote, right? It's if you just said dot capitalize, you would get an error there, right? So this is how we distinguish. If the braces weren't there, it would be something called the field attribute, which is something you're going to learn maybe in a week or so. But for now, just remember that it's important to have these braces there. So we don't call it like this. We don't call it like a function capitalized, which gets the string input hello. We call it like this. Hello is an object, and it has a method called capitalize, and we want to invoke it. And you see what pops out of there is going to be hello, right? So that's the first thing that you have to be aware of, that methods have a different invocation style that we're not used to necessarily. Okay, as I said, we can look up information on any of these string methods. The thing I just need to teach you how to do is read it. All right, so here's a good example of documentation. Sometimes an exam question is, here is the documentation for a method, invoke it, right? So we just want to be able to make sure that you can actually read the documentation for a function or method enough that you can utilize it. So here's the string method for find, right? So it's saying, okay, for a string s, if you call dot find, so these square braces indicate optional parameters. Right? So we don't necessarily have to give optional parameters. That's why they're called optional. But this sub is outside of those square braces. So the way to interpret this is that sub is required, start is optional, and furthermore, end is optional. Right? So you can either give this find one argument, 2 arguments, or 3 arguments. And if we read through the documentation, this is going to return the lowest index in the string where the substring sub is found, such that sub is contained within that string slice. And optional arguments start and end are interpreted as with the slice notation. And importantly, if it fails to find something, it's going to return -1. Right? So it's important so sometimes functions or methods won't be able to do the thing that you're asking for. And it's important then to realize or be told what the error signal is going to be. So in this case, it's going to be a -1. Okay, so let's see if we synthesize that enough to be able to use it. So the square brackets and the parameters for find are this, indicate optional parameters. So this rule recurses. That is to say, optional parameters can have optional parameters. That's why you can have sub, right? So if those two square braces weren't there, then you would have to, this would say you can give me sub and optionally two more parameters, right? This is a way of saying one or two or three more parameters. So something, these are the comprehensive ways that we can call find, right? So I can say in the string team, find I. That's fine. In the string team, find I, starting at index 1, which is also fine. I can also say in team, find the index I, starting at index 1, finishing at index -1, excluding that. So those are all fine. Whereas find 1 minus 1 is not allowed, right? Because as you see here, sub was a required argument to this method, right? So all you need to remember is square braces indicate an optional parameter. Okay, so let's see if we've learned anything. If I call find, can we find hello in hello world? Can we find world if we start at the index 6? Well, let's count. 0, 1, 2, 3, 4, 5, 6. Okay, so starting at 6, can we find world? What is it going to return? We just read through the documentation. Let's go back, right? Return the lowest index in S where we can find the substring. All right, so knowing that, what is this going to return? 6. Perfect. All of you should get ducks for that one. Okay. In hello, hello, can we find hello? Which one does it find, the first one or the second one? First one. Why didn't it find the second one? Because that's not how the method was designed, right? Either sort of decision could be at play, but this is why reading the manual is important, because sometimes decisions are arbitrary, and you need to know what arbitrary decision was made in that case. So what is this going to return? 0. Okay. Can we find hello in hello, hello if we start at index 1? Where are we going to find it? 6, right? Because it's 0. We're excluding this H, right? So we don't find hello until we get to 0, 1, 2, 3, 4, 5, the 6th one. Okay, so 6th index, we do find hello, hello. Can we find hello in hello, hello if we start at index 1 and end at index 3? What will we return in that case? -1, right? Because that was the failure case, right? Okay, good. So we can read documentation. And again, there are hundreds of these types of methods. There's always going to be a method for the thing that you want to do with a string, most likely. Would you be able to write this with using a for loop or something? Would you be able to implement this find as a function? I would hope so. It doesn't seem to be too complicated. You just use enumerate and you try to find it. Was there a question up there? Yes, sir.
In the documentation, does not give us any information of the type that are allowed to be entered in the document.
Well, the type is intrinsic because I asked for help on the type string, right? Yes. Yes.
Does it not give us that information?
Well, I guess in this case, no, but I guess it's intrinsic that start and end are integers, right? We can't have like 1/2 index, right? So, well, Python's not a type language. That's sort of the problem, right? We don't really like talking about types that much. So like, yeah, if you wanted to write documentation which specified that, you could, but they didn't, right? So I think, I believe that this is a sufficient amount of information in order to utilize it, right? Which I think is the true. You don't want to bloat your documentation, right? Writing too much can also be bad. The objective is always clarity. And I believe that this is enough information in order to call it properly. Where were we? Okay, so the following may be accomplished by invoking the appropriate string method correctly. Usually when I did active learning at the University of Toronto, this was a lesson in trying to go through the string list to try to find the appropriate string method, but we won't do that. So, we could have an exercise saying convert a string of text into the title format. And so we have a tale of two cities should be converted into a tale of two cities. What I want you to be able to do here is be like, that probably is a string method that exists. This is not some exotic thing that we're doing with strings. This is a very typical thing that we're doing with strings. Probably the method exists, and therefore you should strive to try to find the method. So as it is, there is a string method called title, and here is how you would use it, right? So we have a string. We've stored that in a variable called Cs. Since Cs is a string, we have access to a method. That's why we're calling it with dot. We're not saying title of strings. We're saying Cs.title invoke. And what you're going to get back is a tale of two cities. I don't know what the second part. Oh, I'm just showing that you can call it either through utilizing the name, or you can call it directly on the string. Okay. Write a function that, given a word and integer width, centers the word in the sequences of x's. Okay, so for this, so I see foo. I want to write some type of function foo, which takes spam and it centers it like that. Like you should be like, the mind should be moving, saying, okay, this again is something probably very common with strings. So you go through the string list and you'd probably find something like string.center. Okay, so let's see if we can read this and utilize this string method in order to accomplish that previous task. So there's a string method called center. You give it a string, you give it a width, and you give it a fill character. Are there any optional parameters in this? No, right? All of them are required. Otherwise, we'd see square braces. So it says padding is done using the specified fill character. Default is space, right? That's what this is. You'll learn about being able to give default parameters to a function quite soon. Right, so then I can just say spam.center in a field width of 10 using padding x, and we're off to the races, right? So there's 101 centered in 20. There is x, and we're off to the races, right? So this lecture is not going to be very long, this string one. It's just I want you to be aware that all objects in Python have built-in methods that accomplish things that are probably very common things to do with that object. And you'll be writing custom objects with custom methods. Okay, so now we're going to start doing file processing. So I want to uncover the important methods that are used quite often in file processing. So for example, we can split this string on spaces, right? So you can take a sentence and you can sort of extract the words from it if you want. That one is quite useful. What will happen, you think, if I split on this, knowing that the default split is space? Okay, well, let's look up the help on it, right? So I can go into here. I can say, okay, give me, I want help on string.split, and we should get the documentation for that. Oops. To Barge. Let me go out. Quit. Okay. So it's split. It takes a string. You can give it a separator whose default value is none. And this returns again, this is not very well. Okay. It says that it's a separator that you can give it. The separator is used to split the string. When set to none, the default value split on any white space. Okay, including new lines. I don't know what that R is actually. Tabs, and I don't know what that F is. We'll discard empty strings from the result. And -1 means no limit. Okay, so effectively I say, okay, there's a separator here. So probably it says the default separator was space. There's no space in this, right? So we're not going to get space. We can split this on X if we want. And then we get that. And then we get great utility out of the string method. Oh, I can split on words, right? So don't forget that there's no such thing as a character in Python. There's always strings. So anything that's going to work on a string of length 1 probably works on strings generally. So what am I going to get if I split this on BX? Yeah, AXC probably, okay? Here's a really good use case, right? So here's a bunch of things separated by commas. What are we going to get if we split on comma? Well, be careful, right? Because there are spaces in here. And remember, space, we're not prejudiced against this character just because it doesn't show anything. But it splits on that. So we're going to have these little spaces in front. This is pretty useful because there's something called the comma-separated value file, a CSV file. That's anything that's sort of represented by a spreadsheet. But how can we sort of clean this up so that we can get rid of those spaces in front? What's a smarter thing to split on if our information is sort of has tailing spaces? Yes, sir. Yeah, so why don't we just say split on comma space, right? And then we're going to get the proper splitting. There's a duck for you, okay? So this is very useful for working with comma separated value files. Again, those are anything that you have a spreadsheet. If you export the spreadsheet as text, that's where you're going to see. You're going to see values separated by commas. We can join things together. I always reverse this somehow, but if you give it, this is the way that you sort of can think about this. You want to take the elements of a list of strings and you want to glue them together, and this is the glue, right? So if I have a list ABC, you can always glue them back together to get the single string A comma B comma C. That's quite useful as well. You can join on empty string, right? That's going to have the effect of taking everything in your list and joining them all together. That's also quite useful. You can take a list and you can join them on comma space. And there you go. There's a line that would be appropriate for writing into a CSV file. And again, you can join on anything that you want. So you can use triple X as your connective tissue and get A, triple X, B, triple X, C. This is a very important one as well. Sometimes your data is going to be messy. There's going to be like tailing space, leading space. So here's the help on strip. So you give it a string. You can give it, character. There's an optional parameter here for characters. And what this does is it's just going to, if I give you a string that has space in it, like leading space, tailing space, and maybe a carriage return, often what you want to do is just grab that data and ignore everything else. And if you use split, oh, I should have had dot split in there. This is a new slide. So I'll just write it in here. Okay, so if I do something like space, 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 1, 2, 3, space, 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 new line character, maybe a tab, and I say strip, where you're going to get back is a sanitized version of that string. And that's very common as well, right? Because this is a big problem in data science. It's called data sanitization because sometimes the data that you're using is dirty, so to speak, or not well formed. Okay, so that's it, right? Because I just want to now we're going to be using strings a lot with file processing. And I wanted in the back of our mind that, hey, we are going to be able to use string methods to accomplish basic things on strings. So we're going to strive to utilize them today. So sometimes data types comes with extra functionality by way of methods. They have a different invocation style than functions. It's not F, give it something. It's the thing dot F with brackets. And these are going to be quite useful with text processing. Okay, so now let's move to file IO, and we're going to program and we're going to do a lot of things, right? Okay, so file IO. Okay, so we talked a little bit about the memory model. The memory model is a little bit more sophisticated than I let on. At first, I just said that memory is just a really long sequence of 0-1 toggles that we can toggle on and off into meaningful configurations. That's not quite the whole story. Okay, so your computers are very fast. The processor can do basically a preposterous amount of mathematical computations per second. But the other thing that it needs to do while computing is maybe write something on the blackboard, remember something. Now, what's the point of having your computer do arithmetic that fast if writing on the blackboard, say, takes an hour? So there's actually two things we're worried about in computer science: the speed of the processor and how fast we can read and write into memory. And the way that the memory model has been configured on a computer is in levels. And each level has advantages and disadvantages. So you have your processor, that's the thing doing the math, and physically beside it, like right beside it in terms of like proximity, is the cache. And the reason it's right beside it is because your computer has to physically move around electrons. So the closer that memory is to the processor, the faster it's going to be able to read write to it. So the first level is called cache, and the cache is usually L1, L2, L3. So this was the profile of my 2016 MacBook Pro back when I was teaching at the University of Toronto. It had access to 256 kilobytes of cache. That's a nothing amount of memory. That's like 256,000 of these switches. That's not a lot, but it's super fast and it's super expensive to manufacture. Okay, so aside from that cache, if we need more, then there's an L3 cache, which is a little bit farther away. That's a little bit larger. That's 8 megabytes. That's a little bit more sensible, but it's slower to read write to, like by orders of magnitude, and it's still quite expensive to make. One level up is called RAM, or random access memory. I'll tell you why it's called that soon. This is where Python operates. When you open the Python REPL, it gets allocated some space in your RAM, and it's possible to fill up that RAM. Suppose we wanted to analyze if all tweets, count the number of tweets that mention Taylor Swift. Do you think that's going to fit into 16 gigabytes of RAM? No, that's impossible. There's probably thousands and thousands of gigabytes of tweets or X's or whatever they're called now, right? So what is required of us is to move up to disk memory. Disk memory is the thing on your computer that effectively stores things, right? And that's usually measured in like gigabytes. 256 gigabytes was what was on my computer. Now, probably the minimum amount of memory on your computer is around 500. Then you can move to the cloud, which is like a functionally infinite amount of storage, like putting something on Dropbox or OneDrive. That just keeps getting, I don't even know how to compute how much memory is there. It's functionally infinite. To give you some perspective, when I was in graduate school, I had access to like I was doing mathematical computation. And because I was doing that, I had permission to utilize Canada's supercomputers. So I had special permission to run on a computer with 16 gigabytes of memory. That wasn't even that long ago. So this is an experiment that I like doing. Who has 16 gigabytes of memory on their machine? Not at least, but precisely that amount. 16? Okay, it's probably 32. Okay, there's 64. Yeah, 128. One time there was someone with 128 gigabytes of RAM on their machine. I don't know why, but I just want to give you an idea about how rapidly these things are increasing. Right? Maybe 10, 15 years ago, I had to have a 16 gigabyte computer was considered a supercomputer back in that era. Okay. The other relevant thing about, so what we have to learn today is learn how to interface between random access memory and disk memory. Random access memory is not going to be large enough if we want to do data processing. The other thing that's relevant here is persistence of the data. The L2, L3, and random access memory require electricity to remember anything. If you turn off your computer, that memory dumps out. It can't work. Your disk does actually remember stuff. Like it uses a magnet to change the polarity of something on the disk, right? So this is the other problem is persistence. Sometime you may want to remember the results of a computation, and if you want that to happen, you have to write to the disk. Okay, so now I'll tell you why it's called random access memory. The way that the disk works is that we have a bunch of wafers, thin wafers. They're all layered, right? So it's really, your hard disk is really like a stack of wafers. Not really, it's solid state devices typically now. So what we used to have to do to find something in memory is have a read head go and try to find the wafer where your information was. Some searching was required. You couldn't just say, go to that bit. RAM is different. RAM says, we don't have wafers. We're a solid state device. You'll learn what that means. But effectively, it says you can just point wherever you want and we'll give you access to that part of memory. That is to say, access to the memory is random, right? So that's why it's called RAM, even though newer types of memory are also solid states. So your disk-based memory acts more like RAM. And that's why it's a hell of a lot faster than the disk-based memory. But today's learning objective is going to be learning how to interface between the random access memory and the disk memory. Right? Pulling from disk memory into RAM and writing from RAM into disk-based memory. Okay, so when Python launches, it gets allocated space in RAM, which is possible to fill up. I can show you how to increase that allocation when we do our little bit of dynamic programming. This is a problem if we want to solve memory-intensive problems like analyzing tweets or payroll or scientific computing. We may also want to save our data with persistence. In either case, we have to learn how to do this interface, because what I don't want you to do is take a file and read it into memory. That totally breaks the whole point of what we're doing. And furthermore, there's going to be cases where you can't do that. You're never going to load all tweets into memory. What we're going to do is we're going to have a perception that a file is just a sequence of lines, which is what it is. Right? If any text, any book is just a sequence of lines with words on it. Now, given that each thing is a line, and what structure of Python do you think exists which is going to facilitate us walking through something? I said this was my favorite control structure. We want to look at one line of the file, the first one, then the second one, then the third one, and then the fourth one. Yeah, the for loop. Right? So we already have an existing control structure, which is going to facilitate walking through memory, and it's going to be quite nice. We're going to be able to say something like for line in the file, do something with the line, right? So that's how we're going to, the way that we have to work with files is by answering questions on that file, by limiting ourselves to looking at one line at a time and throwing away the line after we utilize it. Okay. That's the frame of mind that we have to be in. Okay. So this is the contents of a file. And I'll show you, I also have it here. Okay, so you guys still know what directories are and paths, I hope. Okay, so this is getting lost. Okay, so because you have a phone or an iPad, you no longer have a file system on that. If you want your photos, you open the photo app. That's not classically how we store files on computers. There's something, you have a file, and that file lives in a directory, like a folder, and you have to be able to now traverse this directory structure, right? So this used to be something that we assume students knew. We no longer have this. So I'm going to have to show you a few things now. Okay, so this is my desktop, right? So there's a folder on my computer called desktop. There's also a folder on that desktop called data. And in that folder called data, there's files, right? So I can say that this file, mangle.dat, is at the path desktop data mangle. That's where it is. Okay, so that's going to be relevant, right? So I have, you can see that. So this left-hand column here is showing me all the files on the desktop, right? Starting at the desktop, which we sometimes called root. Root really is as far back you can go on your computer. For you Windows users, probably like C. For your Mac users, I think it's HD. And for Linux users, you don't have to be told. I think you just literally root, right? But you should know that. Okay, so the relevant thing about reading from files is how do we tell Python to find them? Where does it start looking for a file? Okay, because if you just say import hello, right, somehow, Python needs to be able to see it. All right, so here's a file. Its contents is called hello.txt. What I want you to be aware of, you may not see it when you open the file, but how do you get to the next line? If you're typing in a text editor, how do you get to the next line? You have to hit the carriage return, don't you? And because you hit return, a new line character is in that file, even if you don't see it, right? You can sort of, if I open this file, bands.dat, oops, or board, hello, that's the one I want. Okay, you don't see new lines there. I can turn them on if you want, but you probably won't see them. So the first thing that you have to realize is that each of these lines has one extra character, which is the new line character. Okay, so we're going to now, I'm now going to show you how to open a file. You now need to be careful. Okay, so we can read from a file, we can write to a file, and we can append to a file. So I can show you how we do that. Okay, so I'm going to open up Python, and I'm going to try to read in that hello. And we do it like this. Oh, sorry, I'm already in Python. I'm going to try to open that hello.txt for reading. Can't find it. Okay, because Python is looking for the file in its current working directory. So now I need to tell you how to determine what your current working directory is. And this is how you do that. You can import operating system, and then you can say operating system, get my current working directory. And it will tell you what it is. Python's saying, I am currently looking for files in users UQ Verbic desktop, right? So users is considered the root, but the relevant thing is this last thing. It's looking for files on the desktop. Usually it's looking exactly where you've put the file, right? So you should put the file beside that file if you want. But so I have on my desktop a directory called data, and that's where the hello file is. So I can say, oh, okay, I want you to open, go into the folder called data. Then you have to use this /, and then I can say hello.txt for whoops, what is happening? Let me try this again. Open data hello.txt. This is happening again. Hold on. I have to kill this. I want you to end. Okay, let me try again. New one. Okay, let's try this again. OS, oops, imports, operating system, get current working directory. Okay, it's the desktop. Open in a directory called data, hello.txt for, geez, something's really borked. Okay, back up. All right. Import OS, get os.get current working directory. Okay, desktop, I want to open in data a file called hello.txt for reading, and now it can find it. We've opened that file, okay? I really don't understand why this breaks. So I'll try it again. Okay, give me a new terminal. And let's hope that works. Okay, so the one thing I want to warn you about now is the fact that you're a computer scientist or you're becoming a computer scientist. Throughout your career, we're going to give you more and more acute control of your computer. And that means you can permanently destroy your computer. And at the moment, I'm actually giving you the capacity to permanently destroy files. This is a warning, and you should heed this warning. If you open a file for writing, it will overwrite the file of that name in the directory if such a name exists. An overwrite is different than deleting. You're used to deleting it and it going into your recycling bin or trash or whatever in such a way that it's recoverable. This is an irrecoverable thing. If you open a file for writing and there's a file of that name, where you open it, it's gone forever. You can't recover it. So please be careful. I'm now giving you your first command, which is truly a destructive command. It's not going to destroy your computer. Well, it could actually, it depends what files you're overwriting. If you're overwriting operating system files, you potentially may have to reinstall everything on your computer. Later, when we'll give you more acute access to the hardware, and then it is really possible to permanently break your computer. I've worked in laboratories where computers have exploded and stuff like that. Okay, so be careful with writing. Writing is a destructive command, right? If there's a file, and let's see if I can demonstrate that. All right, so here's hello. If I say, okay, so let's open hello. I don't understand why it's doing that. It's really bothering me because I need to be able to show you guys how that's working. I really don't understand. Okay, so if I open, I don't know what to do. Okay, let's go to close this. We'll try reopening it because I really won't be able to teach you effectively without using it. So just give me a second. Okay, let's try again. I don't want you to record that history. I want this trashed out. Okay. Okay, so there's my hello.world or hello text. Okay, so I'm going to go into Python. Let's all cross our fingers. Let's open data hello.text for reading. Perfect. Not for reading, for writing. Now I'm going to say write. That's the file. I'm going to hit enter. Gone. Everything's gone. I can't recover that. It's gone. All right, because it wrote a file with that name, and it starts that file. File is empty. Okay, so this is your warning. I don't want you ruining anything on your computer. Especially, imagine you spent like 4 weeks writing your homework, and then you accidentally overwrote that homework. That would be bad. Okay, so be careful when working with files. It's safer to use append. What append does is if a file exists, it will just add to the end of that file instead of starting that file from anew. All right. So the things here, if you need to look for files starting from root, if they're buried in directories, you have to use this /, and you can establish your current working directory by importing operating system and then getting your current working directory. You can also change your directory if you wish, but that's not something we really do. Okay, so here's how you read from a file. We can say file, open this file hello.text for reading. Let's assume that the file is in the same directory as the current working directory, so that will work fine. Then I can do something like file.readLine, and what it does is it reads the first line, what a, and a new line. I can read the line again, and what we're going to get is wonderful with a new line. And I can read file again, and we're going to get hello world. And that was the last line in the file, like before it got destroyed. Let's see if it's still in. Okay, good. It's still in that buffer, right? So that's the first line that had a new line. That's the second line that had a new line. That's the third line that had a new line. This is the last line. There's no new line, right? So that's one way we could determine the last line of a file. So my question is now, we're at the end of the file because there's no new line. What do you think happens if I read a line now? And this is an unfair question because it depends how. Okay, so let me phrase this differently. We're programming this. We're programming the read line method. What are some options to return here for being at the end of a file? Yes, sir. The empty string. Okay, that's one option, right? Because truly, we'd never be able to read an empty string from a file. The best empty line we could have is the line solely comprised of new line. I like empty as an option. What other options are there? Yes, sir. Pardon me? What's it? Oh, to go back to the beginning of the file. But then I ask, how will we ever, I'm going to give you a duck anyways. How do we know we're at the end of the file ever if we're just looping back? I suppose you detect that the line doesn't have a new line character. Okay, that's acceptable. Okay, so there's two options. I can think of at least two more. Yeah. Yes, miss? Error would be sufficient. You're at end of file. Why not? I don't, errors are kind of hard to work with because if you generate an error, then the whole file crashes out. But soon you'll be learning how to detect errors, so that's not too much of a problem. One more example. Yes, sir?
That's
You just repeatedly print the last line. Yeah, why not? Okay, I'll tell you the last one. In the Unicode table, there's a symbol called EOF that stands for end of file. And this is what you get if you're working in lower level languages like C or something like that. So I'll give myself a duck, okay, for that answer. As it was, that gentleman over there had the correct answer. We're going to be generating the empty string endlessly as you keep calling for new lines. Okay, this doesn't matter because we're never going to traverse files like that. We're going to traverse files using my favorite control structure. Yes, sir.
like our second last line of file is something new lines, and then our next line. How do we know that we're at the end of the file?
What do you, oh, you mean like if I just do this?
Yeah.
But that is the new line character. That is empty, I guess, right?
So
Yeah.
still find out file.
That's actually a good question. What is that? Okay, hold on. Let's see what's there. Uh, let's see. What is happening to my computer? This is so borked. Something must have updated. Anyways, well, just bear with me, everyone, today. I may have technical problems. Okay, so let's call this a file. Open data hello.txt for reading. Okay, so let's start reading from this. Okay, so read line. What a wonderful hello world. Empty. Empty. Okay, yeah, I don't know. So we can't. That's a really good point. So that really screwed. I have an example where we're counting the number of counting the number of empty lines, but it doesn't matter ultimately because we're never going to use read line. We're going to use the for loop to do this, right? And the for loop will just handle this for us. Okay, so good observation. So maybe that wasn't the best way of indicating the last line. Probably EOF would be a little bit better. But anyways, we're going to use a for loop. So I'm going to say file hello.txt, open this for reading. For a line in the file, print line. And what you're going to see is this. Now, why you're seeing these gaps, remember when we print something, let's go here. I'll just try to give this the best chance at recovering. Whoops. Okay, when we print something, hello, you get naturally a new line in that. If I add a new line character to that, it's going to print hello new line and then the new line. Okay, so just be mindful of that when you're printing something with a new line, it generates another new line character. So if I were to traverse that file, like what a wonderful hello world, that's why you're getting those extra ones. But this is how we're going to traverse our way through. We always want to process files line by line. So the for loop is just going to facilitate that quite nicely. You can literally say for line in file, process the line somehow, which is very idiomatic, very English. I love it. Okay, so here's my next question. So we ran that for loop. What happens if I try to for loop again? Well, what are the two options here, you think? Pardon me? Maybe the last line gets printed. Maybe it does it all over again. But neither of those things are the case. What happens here is nothing happens. So how the operating system is handling interfacing into a file is that it has something called a file pointer, and it's pointing at a line. And every time you read a line, that pointer goes down. And what the for loop has done is moved it all the way to the bottom. So the next time you call that for loop, the file pointer is still at the bottom, right? So if you re-execute a for loop, it's not going to retraverse the file. So what you have to do is then reopen the file, and this will reset the file pointer to the top of the file, right? So if you wanted to traverse a file twice, which you shouldn't, right? Like you really ought to do all the processing required traversing that file once. These things are big, and furthermore, read writing is very, it's an intensive operating system imperative. Let's put it like that. You can really destroy any of your computational speed by read writing too fast. Computer science, you'll find, is a dual problem of managing memory and managing complexity. I forgot to mention, so the one thing that you're not doing in Python is managing memory, right? So I like to make this analogy. It's like I'm trying to teach you all how to drive a car. And I'm teaching you how to drive an automatic car, right? So we can focus on learning how to steer and following the rules and signaling. And next year, we have to introduce the gear shifter. We have to teach you how to drive a manual car. You have to do all the shifting yourself. So next year, you're going to have to do all the memory management yourself. That's what's going to be complicated about C. But it's good that we get to focus on one thing before the. Who does know how to drive a manual car? I drive a manual car. Yo, wow, good for you guys. Yeah, we're holding the line. I hope it's harder and harder to find manual cars nowadays. Okay, so again, if you want to reset the file pointer to the top, you just reopen the file pointer goes to the top, and you can retraverse the file, though this is not advisable. You typically shouldn't be traversing a file twice, although there may be cases where like there's no other way of accomplishing the task that you want aside from traversing the file twice. Okay, if you do not close files, they remain vulnerable and prone to side effects. Okay, you may find some of your file missing or garbage there. The first programming job I ever had, I was quite embarrassed because I computed something and I was writing it to a file and parts of that file were missing. And I had to go to my boss and say, hey, I don't know what's going on. And he said, Paul, you didn't close your file. And then he like hit me over the head with a piece of paper, right? Because good programmers, as soon as you write file open, you should immediately write file close and be programming in between those two constructs. I'm going to make this a little bit not necessary because I'm going to introduce the with structure, but I'll show you what I'm talking about, just to give you some idea about how the operating system is working in this case. Okay, so it's going to open that. Hopefully this thing is not going to complain anymore. Otherwise, I'll just move it back to the bottom. Okay, so what I'm going to do is I'm just going to open, where am I? Oh, I'm in the wrong place. Okay. Code here. Okay, there's my desktop. There's my data. Okay, so let me see. Let me open this hello.txt. I'm going to empty it. Okay, I'm going to open up Python. I'm going to say file pointer. Let's open data hello.txt. And this time I'm going to say for writing. Okay. So instead of reading, now we can write. I believe it's just called write. Let me look. I think it's right. I think it's right. It has to be right. Okay. Okay, so here's a file pointer, and I can say let's write something, and I say where, right, is my stuff. I'm writing to that file. This is the write imperative. That's the file. Where's the stuff? Writing and reading from disk is expensive, and the operating system is lazy. I say, oh, Python, write the word is to hello.txt, and it goes, oh, not yet. Maybe you want me to write maybe you want me to write a bunch of stuff. I'm going to wait for you to write more stuff. So in truth, where is my stuff is holding in something called the write buffer. And that buffer isn't going to clear until you execute the close command. But this is sort of not always true. Sometimes if the operating system is like feels like it will flush the buffer. It's sort of a non-deterministic type of action. But if you see here, if I say close, then it gets written to it. Okay, so good programmers close files. As soon as you open them, you should close them. You should almost be programming in between the open and close. And as it happens, we have a control structure in Python that is going to automate the opening and closing of files. And we should use it because this simplifies a bunch of stuff. So there's something called the with construct. So to open a file, you can say with open a file in some type of mode, in this case is for reading, as you give the file some name, typically file, and then inside that control structure, that is to say anything at 4 spaces in at an indent level will have access to that file. And when you're finished, with is just going to close the file for you, right? So you can utilize whatever approach that you like, opening the file and closing it manually, but I prefer using with. All of your tutors will use with. We're using with in your solutions. I recommend using with. Okay, so that's all you really need to know about files. We can open them, but you have to sort of ask for them starting from your current working directory. We can read from them, which is safe. We can write to them, which is unsafe, because if you write to a file that pre-exists, it's going to empty it. And we can also append to a file, and appending from a file basically just continuously adds to the end of the file. So now what I want to do is just program a bunch of stuff on files so we can get some practice with them. And the first one I want to do is write a function that counts the number of empty lines. That is lines that only contain a new line character in a file. Okay, so let's go here. I'm going to expose my phone number in Canada. There, that's my phone number, old phone number in Canada, 905-64-1821. When I moved to Australia, I was quite irritated because I didn't know how to ring anyone, because there's all these like hidden incantations that you have to dial before you dial someone's phone number. In Canada, every phone number has that exact same structure. Not the case here. Okay, so let's try to open that file and then count the number of like empty lines in it. So I'll just put some empty lines, right? So there's 1, 2, 3, 4, 5 empty lines in this file. I need maybe something to type in. So, okay, so there's Sandbox. Okay, so let's start programming. So I want to have something like number of, I'll maybe move this here, number of empty lines. And we're going to return an integer. So we have to accept a file, but we have to talk about what that means, okay? Oops. Okay, so there are two philosophies now with working with files. Either we can take as input the file, like someone's opened it and handed it over to us, or we can take the name of the file and we will open it. So I'm going to do it both ways. So the first way, let's say this file is a string, right? That is the path to the file, the name of the file, and we sort of want to return the number of empty lines in the file. Okay, so let's do that. Okay, so the first thing I want to do maybe is open the file. So I'm going to say with open file for reading as the file, maybe, or maybe I'll call this path. Let's call that path. That's a little bit better. So open that file at that path as file. Okay, and then I can just use a for loop for a line in the file. If the line is equal to new line character, which we designated as the thing an empty line is, maybe I want to increase some accumulator, right? This is the accumulator pattern is the one that we just did over and over and over again last week. So probably want to start this accumulator at 0, add to that accumulator, and then return it. Okay, so let's see if that works. Let's go out, let's go in. Python, I want to interact on Sandbox. Okay, so I want to say number of empty line, I should have pluralized that, in data numbers dot dat. And we get nothing back. Why do we get nothing back? I forgot to return something. So let's return something. Let's try again. 0. That's not working. Okay, so let's debug. What is happening? Let's just see if we can print these lines. Maybe I didn't open the file properly. So it's always good to try and do a little bit of debugging. Let's see this. Okay, so it seems that we're not actually we're not actually counting. Why aren't we counting? This is bizarre. Did anyone see my mistake? This is bizarre. Okay, let's see. Maybe if pardon me? Oh, maybe, yeah, maybe it has to be that. No, I don't think so. This is very bizarre. Oh, I know. I didn't save this. See that circle there? That means that hasn't been saved. So I'll save it. Now that's saved. Now this should work. See, programming can be tricky sometimes. It's all about details. Right. I don't need that print. There we go. That error. It's 5. Okay. See, 1, 2, 3, 4, 5. And if I put a bunch more and save it, there we go. Okay. So that's the first version. That's where we take the path as a string and open the file. Let's now do it so that the user has to open the file. So I'm just going to say we no longer need this. I'm just going to scale this back, and I'm going to accept the file pointer now. Now, the doc hint for this doesn't exist yet. Right? Doc hinting is sort of a new feature of Python. So I can show you how to call it in. Yes, miss? How you going? Sorry. So we have to import it for the time being. But I'm very confident that this is going to be put into the system. 3 years ago, when I was teaching this, all the doc hints had to be imported, right? So they're slowly being added. So right now, we're just going to bring in this custom one, right? So from the typing library, import text.io, and I can say this is now a text.io, has a text.io doc hint, okay? This is going to be brought into the system very soon. I'm quite sure of it. Okay, so now it's on the user to open the file and pass, right? So this has a little bit of a different structure. So now I can say, okay, I'm going to open a file. I usually call it FP for file pointer. So let's open data numbers.dat for reading. Notice here that I forgot to include that, which should indicate to you that the default open, I believe, is for read. And now I can say number of empty lines in here. Whoops. That should be that. So I can open that. Now I can pass it to that and get an answer. And since I'm a good programmer, we close. Okay, so those are the two ways that we can work with files. We accept the file name and we open it, or the user opens it and passes it to us. There are uses for both of those. For the rest of the class, I'm going to do it in such a way where we open the file, just because it requires for me to do a lot less typing into the REPL, but both are fine. Okay. Suppose we want to read the numbers from a file into a list, right? This is very common. So you got a number, 1, 2, 3, 4, 5, 6. What we want to do is we want to read this in and then return maybe a list, and that list has 1, 2, 3, 4, 5, 6. Right? Now this is sort of getting into sort of data processing or data sciences. So I have a file here. Where is it? It's in data. It's called numbers. Okay. Oh, yeah, that was my phone number. So I'm just going to remove those empty lines. And let's see if we can read those numbers into a file. So there's my sandbox. All right. And I'll say, what did I call this? Oh, okay, I'll just say read numbers. Read numbers, and I'm going to take a path, which is the name of the file, as a string, and I'm going to return a list of integers. And we're going to return a list comprised of the numbers found at each line of the file at path. Something like this. Okay, so the first thing I want to do is open the file. So with open that file for reading. Oh, and we should also have a precondition. Precondition. The file at path exists and only has numbers in it. All right, so otherwise, if there's like non-digits in that file, that's not our issue. The user failed to satisfy a precondition and blew the contract with us. With open as file, I will say for line in the file, and I want to start with an accumulator. So I'm accumulating an answer. What should the accumulator start at? Remember, we can just look at the return type, and usually the accumulator starts at the smallest thing of the return type. Empty list in this case, right? So there's a list, and what I want to do something is like to that list, I want to append, take the line, and convert it to an integer. And let's see if that works. Whoops. Well, I forgot to, return something. Yes, return the accumulator. Thank you. Okay, so read numbers from data numbers.dat for reading. Oh, sorry. Read numbers from that file, 905, 684, 1821. Right, and we could, suppose this had like empty lines in it or had other things. We could use the string method isDigit to say, okay, only when it is a digit. Well, maybe we should do that, right? Because there's something, you can always ask if a string is a digit, even if it has a new line in it, I believe. Let's see. Oh, false. Okay, so the nice thing about object-oriented programming, which you're going to learn soon, is that you can string together these type of these methods. What method did we have that sanitizes a line? Strip, okay? So strip is going to get rid of that new line character. And then I can ask if that is a digit, right? So this is the object-oriented approach, right? You have an object and you execute a sequence of methods on it, okay? So this would fail, for example, if this was letters, okay? So suppose now I put in letters like this and even empty lines maybe. we could modify this to say for line in the file, if line dot strip dot is digit, okay, then do it. Otherwise, don't do it. Right? We don't need an else branch, right? We're only saying do this when that condition is met. And then that should, whoops. Oh, jeez. There we go, right? We had a file, there's like non-numbers in it, and we managed just to ignore them, right? So this is sort of the beginning of data sciences and data cleaning and stuff of that nature. Working with files is kind of tricky. They're never really organized the way that we want. Okay, so when reading from a file, we're always reading strings. So remember that we had to do a casting here, right? If we didn't put this line in, this integer thing here, we would not have got the outcome that we wanted. Right? That's a little bit different. Those aren't numbers. Those are strings. So don't forget, just because you see something may look good. Like for example, if you print a number and you print the string, they will look identical. Right? So these are hard bugs to track if you're using print, right? So just be careful that you're utilizing conversions when necessary. Okay, so there's the answer for that. Okay, here's a fun one. So this is like a more typical use case scenario. I don't think this is something that you may necessarily be able to do in Google Sheets or Excel or something like that. So I have a file. It's over here. It's in data bands. And it's a comma separated value. This is basically what a spreadsheet looks like if you export it into raw data. And the first line is something that we call a header. It indicates what each column is going to be. So the first column is a band, the second column is a rating, and the next number is plays. Let's write a function that is going to answer the question, which artist has the most number of plays in this list? And I've updated this for the era, I suppose. So what's the answer going to be? We should have an idea of what we're looking for before we program. Who's the most famous artist according to plays in this list? Taylor Swift, Swifties. Who's the least popular artist? How many plays did it require to designate him as 0 in terms of rating? 1. Okay, so that's what we need to remember because we're going to do 2. We're going to do best artist and then worst artist. Worst artist will be easier in some respects. Okay, so that's the goal. This is the file, right? There are lines that are comma separated value lines, and we're going to have to do some processing on this. So we're going to do something like def most played band, right? Because there's 2 ways we can do this. We can do this by plays or do you want to do this by plays or rating? It doesn't really make a difference. Okay, let's do rating. Rating is different than the solution, right? So this will give you something new. Okay, so we're going to find the best band by rating. Taylor Swift is rated an 11, so that's who we're still trying to find. So we're going to take a path, and we're going to return a string because we're going to return the name of the artist this time, and it's just going to be something like return the most popular artist by plays. We have a precondition. The file at path is a CSV file, with header, band, rating, number, and place, something like this. Okay, and it's a little bit harder to give docstring examples here because you have to pretend to open a file and stuff like that. So I'm just going to omit that for the time being. Okay, so let's just think what we have to do. Bare minimum, we're going to have to look at every line of this file. So let's just start there. I'm going to open the file open the file at path for reading. We don't need to write to it. We're typically only reading from files in this class. I'm going to call it file, and let's not do too much. For a line in the file, let's just print the line, and we'll return nothing for the time being. Right? We don't want to do too much because in the case that we've done something wrong, if we've typed too much, we won't know where to look. Okay, so most played by rating. I want to look in data. I think it's called bands.txt. It doesn't exist. What did I call it? See, it's why I don't want to do too much. Bands.dat. Okay. Okay. So I've managed to open the file, look at each line and print it. So I'm definitely looking at each line of the file. What's the next thing that we want to do? Well, we need to look at these lines and we need to decompact them. We need to separate them so we can look at each field. Do we have any type of string method which is going to help with this? Which one was it, miss? Do you remember? Split. Yeah. So remember that we can take anything that's separated by commas and split it. That's going to be quite relevant here. Okay, so I'm going to go into here, and at each line, I'm going to split that line, and then I'm going to use tuple unpacking. I'm going to say, because like there's three things there now, right? And so if I took ABC and split it like that, yes, sir. Yes, I want to split it on comma. Thank you for that. Uh, yes, that didn't do anything. Split it on comma. Okay, great. Okay, so I can use tuple unpacking here to say X, Y, Z is equal to that. And you'll see X gets A, Y gets B, Z gets C, right? We don't need like 3 lines in order to do this. We can do this in 1 line without indexing. So what I'm going to do here, what was it again? Yeah, band, rating, and plays. Okay. Have we already made a mistake here though? Let's think through this. There's the file. When I do this, what's the first line that's extracted from this file? Yes, miss? Band rating plays. Should we be including that in our processing? No. So what should we do? Well, in plain English, what should we do is we should skip that line. How can we skip that line? Pardon me? Yeah, we do one read line. It's a great answer, right? So before I even go into the file, I'm just going to say read a line and just throw it away. This is an instruction to move the file pointer down by 1. This is the perfect place for an inline comment. Skip the header. Okay? Because a programmer looking at line 11 is going, why are you reading a line before traversing the file? Oh, there's a header. We need to skip it. Right? So this is quite exemplary as a perfect place to do an inline type of comment. Okay, so now we've skipped the line. At each traversal, we're grabbing band rating plays. So what's the objective here? Well, we want the most played band. That has to be equal to something to start. We'll talk about it. And the number, like most number, it's ratings. Highest rated band and highest rating. And we'll think about, we'll return to this because we'll have to set these to something. I just can't spin up variables and not put anything in there. But let's see what we're going to do with them. Because I need to do something like this. If the highest rating is is less than the rating that we just pulled out, then actually the highest rating is the rating that we're looking at currently. And the highest rated band is therefore the band that we're looking at currently. Okay, so, and then what we want to do is return the highest rated band. So the question is, what default value should we set at 10 and 11 with this in mind? Okay, so suppose we start them off with like basically nothing in them. What should happen like at line 2 for Metallica? Look at that if statement. If we only looked at one band so far, who's the highest rated band? Metallica. It's the first thing that we look at by definition has to be currently the highest rated band and the most and with the highest rating. So therefore, logically, in the logical control flow of this program, we have to ensure that line 18 is guaranteed to trigger at least the first time through. So the question then is, what should I set 10 and 11 to guarantee that line 18 is going to trigger the first time we encounter it? Well, okay, so what is being controlled at line 18? What proposition? We're comparing the current rating with what's currently in highest rating. So what can highest rating be set to in order to guarantee that any rating is larger than it? Yeah. Pardon me? Can we compare strings with numbers? No, so it can't be empty string. We're getting there, yeah. -1. Okay, so if we look through here, it seems that the lowest rating is 0. If the lowest rating was -1, I would have given Drake -1 rating, right? Okay, so if we know ahead of time that ratings have a minimum value of 0, which is sensible, then -1 would be an appropriate value there. Okay, problem. What if that's not the case? Yes, sir. Pardon me? We can't compare none. What number is lower than every number? Yes, sir?
we skip this first line, then we'll work on the next line.
Yeah, but you're going to do code duplication, and that's a sin, right? Well, truly. What number is smaller than every number? Yeah. Yeah. Remember I told you about this on day one? Probably not, but you do have infinity on the system. How is that possible, sir? Your computer can't store all the numbers. Therefore, one of the numbers is the smallest. That's negative infinity effectively on your computer. So you do have access to that. So really, I set the first rating at minus infinity. That's why this is provisioned for exactly scenarios like this, right? Because this is more flexible than using -1. Although I do acknowledge that if we knew ahead of time that the lowest rating was 0, -1 would be totally fine. But minus infinity is more robust in this setting. What should we set highest rated band to? It doesn't matter, really. Empty string would be fine. None would be fine, but it's not being compared with anything. We just have to put anything in it. It's guaranteed to be overwritten the first time we launch this. Okay, so let's see if this will work. Okay, most played by rating for data and bands.dat. Ooh, oh, not line. Silly me. File. Yes. It really irritates me that that's highlighted. File used to be a reserved word in Python too, and they haven't removed it from the syntax highlighting yet. Okay. Oh, geez. Okay, what else did I screw up here? I just yelled at you guys to not forget to do this, and then I forgot to do it. So what's the mistake? Yes, miss? Yeah, these are strings, right, at this point, right? So I have to say rating gets integer version of rating. Okay, so now this should work. No, it would tell me if that was the case. Where do you suppose the indentation error is? Oh, Lord. Yes. Yes, it has to be in the loop. You're correct. I had a mistake in that wasn't an error. Error would have told me you have an indentation error. That was just a mistake, a logical mistake. Okay. Oh God, certainly not the case. Oh geez. Okay. Good. Taylor Swift. Okay, let's see if we change this just to see if I make this really big, if that will trigger. What? Did I not save it? Oh, sorry, wrong. Rating, yeah, rating, 80. Okay, perfect. Okay, very quickly, let's do the other one. Lowest rated. This is going to be much easier. Return the least popular artist by plays, or that's actually, that should have been rating. By rating. Right. Okay. Turn Drake, and we are right. Lowest rating. Data bands.dat. Perfect. Okay, there's the other one. Much easier. All fun complexity, right? Just returns Drake for forever. Okay, if you don't, that's a joke, everyone. That's not actual implementation. Okay, so there's the listing. The listings are also going to magically show up in about 45 minutes. Here's an exercise that you should try at home, right? Suppose, one more thing I wanted to mention, actually. You see how that place here is a little bit gray? We didn't utilize that variable anywhere in this program. Yes, sir? Oh. No, but somehow it didn't complain. Do you see how that's gray here? So this is my linter. This is my IDE signaling to me. This is strange. You've declared a variable and you've never used it. Okay, so because we're using this as a placeholder in variable unpacking, we shouldn't actually use that. We use an underscore in this case. So the underscore was the single exception to symbols being utilized in names. And one of the reasons we use them is for tuple unpacking, saying, look, I don't actually care to grab that value, but I do require it as a placeholder, right? So if you want to do something, you could do something like this, right? If you wanted to pull out just the middle number of something like that without your linter. The other one wasn't incorrect. It's just sort of bad styling. Like you are going to get warnings that you've utilized a variable and you've assigned a variable and haven't used it. Okay, so this is one that you can try at home. So suppose you have now a CSV file and it has an arbitrary header. You don't necessarily know what's in that header. It can be of like, it could be name, grade, age. So write a function that I'm going to give you a file which has a header, and I'm going to give you one of the attributes. I may say, here's a file, there's a CSV in it, grade, find the largest grade, or find the largest name associated with grade, right? That'll give you a little bit of practice utilizing files. This is the one that I want to finalize doing string processing or file processing on. This is something that our students had to do a couple years ago when the first the project that they were doing was Sudoku. And what we had is we had a board. We gave them boards that looked like this. Where is it? Board. Okay. So we basically said, look, this is the starting configuration of the board. Read this into a list. And the way that we want to read this into a list is that we have a list of lists where each list is a row, and we want actual numbers there. And instead of having empty spaces, we're going to put none, right? So maybe the first row of this is going to be 6, 8, 5, 1, 3, none, none, 4, 7. So let's try to program this because it's like less innocent than it may look. I'm going to do it in two ways, sort of using the imperative approach, and then I'll show you how to tidy it up using list comprehensions, right? Because there's going to be a lot of accumulation here. Okay, so let's try that. So I'm going to do something called a read board. We're going to take a path that's as a string, and we're going to return a list, okay, of lists, and the list is going to be comprised of integers or the value none. That's how you can type hint that. If there's like two types, right? You can use this vertical bar. That's a symbol for or, actually. And I'll just say return a board representation of lists. Okay. I have a more rich doc string in the solutions that you can take a look at. Okay. So the first thing I want to do, let's just open the file. So open the thing at path for reading as file. And let's just say for line in the file, print the line just to see that we're touching everything. Why are you complaining? Oh, in the file. Okay. All right, so read board. And I'm going to say data / board.dat and get that. Okay. I don't want to keep typing this in over and over and over again. So I'm going to do something now. You should have learned in your first tutorial or applied class or whatever we're calling them now that if we have something like this, if name equals main, I can stow a bunch of commands in here so that if I just run Python, it's going to run the things here. I don't want to keep retyping everything. So in particular, I'm just going to say read board of data boards. Oh, yeah, data board.dat. It's just going to save me some typing. So now I can say P3 sandbox, and boom, it does it. Okay, so just remember, anything you put in here is just going to be executed. Saves me from typing. Okay, so we can look at every line. So what do we want to basically do? Well, I want to create a board. That's a list. Eventually, I want to return that board. And what I want to do is for each line in the file, I want to accumulate a row. And that row starts from here. So how can we accumulate the row? Well, each line is going to look like this or look like that. And I don't want to process lines that look like that. So what I'm going to do is say, if the line, let's say this, if dash is in the line, okay, then we can conclude it's a divider, correct? That's the only lines with dashes in them are those dividers. So how can I then say, skip this iteration, don't do anything? Yes, sir. The for loop is automating read lines for us. So we don't need to read a line, but would that work? I think that would work, but that's okay. I'm going to give you a duck. That would technically work. It would technically work, but that's not the answer I'm looking for, right? Yes, sir. Not pass. Pass is the empty Python instruction. Anyone have it? I'll give you a duck anyways. Yes. Continue. Okay. You got a sticker and a yeah, there you go. Double. Okay. So remember continue, right? Continue is the keyword that says skip this iteration. I don't want to do anything. So skip the divider lines. right? That'd be an appropriate place for something like this. Okay, so we know at this point that we're not dealing with a divider line, that we have some type of line that looks like this. So again, I have to write another accumulator. I need to say something like for x in the line, if x is a digit, oh, I'm just being lazy, is digit. If it's a digit, then go ahead and accumulate it to the row. Otherwise, if x is equal to the empty space, not the empty string, but really a gap, right? One space, then I want to row dot append, append integer x, otherwise append none. Otherwise, the only other option is a vertical line, so we don't do anything, right? So that should work. So let's see if we run this, what comes out. Oh, and then we have a row, and I want to take that board and append the row. Oops, and I should print this. Let's see what comes out of there. I could fold that away. Ta-da! Okay, it's kind of long. We can fix this, right? Because I said we have comprehensions, which are a shortcut for doing accumulations. And we've done a bunch of accumulations in here. In the function, when I give you the lecture in functional programming, I'll write you the one-line version that does this, right? Everything in functional programming is one line. But very least, let's try to get rid of this inner accumulator. Let's see if we can build row using one line only. And there's one thing I have to teach you. It's actually possible to have an inline if statement. Okay, so I'll show you something in Python. So we can have if statements. I can say print hello if 1 is greater than 2, else print goodbye. Okay? Oh my Lord. Print hello if 1 is greater than 2, else print goodbye. Goodbye. Okay, so that's a way of doing a one-line if statement. I can reverse that. You know, if 1 is greater than 0. Okay, so it's just a way of getting a single. So if you have an if statement that's really truly an if-else branch, like exactly two things, you're allowed to write that in one line. You don't really need to know that. I'm just showing you because it's going to help me here. So in this row, I want to accumulate something. I want to accumulate x for x in the line if x is not equal to the divider. And I want x to be int x if x is digit, else none. So it's a little bit long. Okay, so I can package that whole accumulation package in one thing. I'm saying, go through the list, right? Pick out all the things that aren't dividers. If the thing you've picked out is a digit, then put integer over it, else it's none. And let's see if this will work as well. It works as well. And because the thing above this is, we're also accumulating on board. So I can actually do another list comprehension for that board and get some really long statement. But I think at that point, we're like losing clarity. All right, so there's how you can sort of utilize the comprehension pattern in this if you want. Don't be too worried if you don't want to do it this way. This is a little bit more advanced. Like doing it with the accumulator with a for loop is totally fine with us. Okay. I just want to show the other option for those who may want to do it that way. So you can try that. Try this one. Okay, so I guess I just gave you a function for reading in a board. Write a function that tells me if the position, if I give you a full board, tell me if that actually satisfies the Sudoku rules. Like tell me if the thing has won. Right? Because one of the things that our students had to do is, given a board configuration, say this is a winning condition or this is not a winning condition. And that's a little bit tricky. That's going to be good practice for your midterm, right? Given something that looks like this, tell me if it's one, right? If there's none in it, obviously it can't be a winning board, right? Because everything has to be filled in. Do you all know the rules of Sudoku? No. Oh, geez. Maybe I should have started there. The things I assume are still things. They're fun. So Sudoku is a game where you have what is it? So 3, 6, it's a 9x9 grid. And the 9x9 grid is broken into 9 subgrids. of 9 positions. And the objective is to fill in the board so that every position has exactly the numbers 1 through every row has exactly the numbers 1 through 9. Every column has exactly the numbers 1 through 9. And every grid, subgrid, has the values 1 through 9. Spoiler, in the functional programming class, I'm going to write a program that solves Sudoku boards using the backtracking algorithm. It's really cool. You can think about how you may try to solve that. So come excited for that. I love that giving the class on dynamic programming and recursion is my favorite class to give. Okay, writing to files. In this class, I don't think you're going to be writing to files very often. Usually this is only required of you if you're like computing some data that you need to store, right? So all you really need to know is that you can open a file for writing and then write to that file using the write command. Just know that if you open a file for writing, the file is going to sort of disappear. So be very careful utilizing writing, right? So there's your warning. Appending to a file appending is safer. So maybe you probably should never use write as like right now. You should only open files for appending because this will ensure you're never going to destroy any type of file, right? So maybe for the time being, use append. This only gets a little bit annoying because every time you rerun your program, that file may be getting longer and longer and longer. And you may actually want to start it off from scratch. Okay, so we can read from strings from files. We can write strings to files. And we can move a pointer down that file by using a for loop. That's how you're going to use it. So also make sure to close your files, but you can just avoid that peril by using the with construct. Okay, so the last thing I want to do with the last sort of 20 minutes that I have is tell you a little bit about testing and debugging. So testing, I'm just going to have a little bit more, I'm going to refresh my coffee. There's 1 duck left up for grabs. I'll buy more. And again, shirts. I'll post something about the shirts if someone wants to buy a shirt. Okay. So we're going to do a little bit of testing and we're going to do docstring testing. So some of you may be agitated that we've been forcing you to write docstrings with examples in it, but I'll tell you that there is a reason for this. So I'm just going to implement the factorial function. I'm going to do it wrong in many ways, just for illustration purposes. So return the factorial of n factorial. And I'm going to put in a couple use examples. So factorial of 0 is 1. And factorial of 3 is 6. I'm going to implement this. So we have an answer. Let's start it from 0. I'm going to say for range, for x in range answer, take answer and multiply it by x and then return answer. I'm aware that this is broken in a variety of ways. Okay. What we can do is import something called doctest. And what these are here are tests. Aren't we? We're asserting the truth of this somehow. So actually, Python can go ahead and run these for you and make sure that your function is actually performing what you're saying that it's doing in the docstring. So I'll show you how that works. So I'm going to go out. Let's go in to sandbox. Okay, so we have this factorial function. Okay, so it's wrong. Okay, so I can say doctest.testmod. And it's going to say, hey, you said factorial of 0 is supposed to be 1, and I got 0. Hey, you said factorial of 3 is supposed to be 6, and I got 0. So actually, this obligation we've been telling you of giving good use case examples, you've been embedding tests into your programs this entire time. And now I'm telling you how to actually have Python check that, right? So we're just trying to give you guys good habits for when you go out in the world. Test-driven development is very important. It is very hard to write software. The complexity of that software scales up as it gets bigger and bigger and bigger. It gets very difficult. Like your phone requires updates. The best, smartest people in this world are screwing up the software that's getting deployed onto your system. This isn't easy to build software that's correct, right? So starting before you even write code, thinking about what that code should do when it's correct is important. That should be your starting point. And then when you're writing, then you can run this tester to check if everything is working. This is sort of baby testing, right? But it's good. Can we fix this now? And I'm just going to keep running this until we pass all tests. Anyone can uncover problems in this function as written. There's 1 duck left. Yes, sir? Okay. Yeah, I'm accumulating on answer. I'm multiplying answer, but the answer starts at 0. So therefore, every multiplication of 0 is going to be what? So this function is just a very fancy function for returning the constant 0. Okay, so that's the first correction. Still broken. Oh, I have to load that back in. Still broken. Okay, so look at, I'm going to type in a main function. So, and then someone tell me what the next problem is. Equal mean. Test mod. Test mod. Okay. Anyone know of another problem? Next problem? Yes, sir. Yeah, range starts at 0 and ends at answer -1. We really need to go from 1 and go to answer +1, right? We want to include the answer and we want to skip 0. Okay, let's try more. Still wrong? Yes, sir. Yeah, I shouldn't be going to answer. I want to go to X. Or sorry, N is the thing I want to take the factorial of. Let's see now. Okay, no complaints. Okay, so it's working. Okay, so if you want to see even when it's working, you can say be verbose. Verbose is what I am, using more words than necessary. And then you'll see expecting factor 0, expecting 1. Okay, you got 1. Factor 3, expecting 6. Okay, you got 6. Okay, so this is how you can actually with your doc tests, if you program them properly, you can actually have Python check them. Okay, so that was that example. Okay, now I have to tell you about a little bit of perils using this. And generally what so here's a question. How many tests do you think are necessary to be absolutely certain that a piece of software is correct? Impossible. Okay, so there's a field of computer science that you can take at the 3rd level called software verification. We can come up with mathematical proofs that software is doing what it is supposed to be doing, but that is very, very difficult and typically not done. It is done on things like, a Tesla's braking system. That is something pretty critically important. Should not, like your brakes can't sometimes work on your car. Like that is something that we do and should verify. So then the question becomes, well, then what is sort of the vibe of testing? And well, I'll tell you, basically, this is what you sort of should strive for. You should have a test that tests typical cases, like 3 factorial. That's like typically what someone would use. You should have tests that test the edges. Those are the important ones. So it's usually, so like 0 factorial was kind of special, right? So we should test 0 factorial. Something like 2 to the power of 0 is special. Okay? So you want it, the edges are sort of like, if you look at your data type, what's at the beginning and what's at the end. So for lists, if you were to order them by length, the empty list is first, and kind of the empty list is special, and kind of the empty string is special. Like, so you should always make sure to include these so-called edge cases in your testing. You typically want to include the literal smallest thing in the data type, like 0, empty string, or empty list. Sometimes singleton things, like sometimes like, if you're sorting a list by doing swapping, can you sort the list with one thing in it? Are you able, like, did you account for the fact the list needs to swap the same element? So that's called the singleton list. Maybe the same thing should be true of strings with one thing in it. The other thing I see is people saying, oh, should we test? We have factorial. Should we write test ensuring that the user has passed the integer? What do you think the answer to that is? No, right? So remember, these preconditions are things that we assume that have been satisfied. If the user isn't satisfying the precondition, there's like the game is off, right? Because otherwise, how many ways can a user pass not an integer to your function? Infinite amount of ways. We can create custom. You'll never be able to account for all the wrong ways the user can call your function. So our starting point is that the contract has been satisfied. So you're not writing tests saying, if the user passed in a string that I should return this. No, you're testing for correctness under the assumption that the program contract has been satisfied. Furthermore, okay, so going back to here, do you think it would have been purposeful to do something like this? Or maybe 4. Is there really a difference between the test at line 9 and the test at line 11? No, that's redundant. Okay, so really, the perfect testing apparatus would be one that tests a use case, a typical use case, all of the weird exotic ways that you can call the function. Remember, you're supposed to be trying to break this. And then maybe I try factorial of the largest number and see if that really works. But that's a different edge. Two AI companies, I believe it's OpenAI and someone else, they actually swapped and tried to break each other's software. Right? That's really the space that you have to be in. You're not trying to prove your function works. You're trying to prove that it's broken. Really, and really the best way is literally to hand it off to some type of adversary in this case. This is not trivial. Testing is extremely important. You can get hired at companies as a quality assurance analyst, and these people are quite smart. The other thing that you have to ensure your tests do is touch every line of your function. If you go to an arbitrary line of your function, one of your tests should execute that line. Everything should be reachable by at least one of your tests. That's called coverage, right? Because if you have big if statements for which blocks are never getting executed by one of your tests, you've missed stuff, right? So typical cases, edge cases, every line is triggered by at least one of your tests, no redundant tests, right? If we showed you the testing apparatus for A1, it is like 10 times more number of code than the thing that you're submitting, right? It's very difficult for us to write the grade scope test that you're testing on. The other thing I want to say is, like, some of you will get agitated that we can't provide better error messaging. Like, all of us wish we could provide better error messaging. Like, we all want to be told where we just can't do it. We're not withholding information from you. It's hard to know how your function is broken. Like, we can't automate that. Sometimes the best we can say is, I don't know, you crashed out, right? So just keep that in mind, that if we could give you better error, and we tried to write better error reporting, but don't feel like we're trying to withhold information from you. We're really trying to help. Okay. So this isn't comparing white space. And here's the problem. Okay. So we're not comparing values. We're comparing strings. So whereas this is equal to this, like as a value, the empty list is equal to the empty list. But as a string, the empty list is not equal to this list with spaces in it. And the problem is, when you print something, Python standardizes the way things get. Oh, geez. Sorry. I shouldn't have printed. Lord. Sorry, guys. If I do this, oh, okay, maybe that's been changed. Okay, in any case, maybe I should do, okay, let me try one more thing. Def, I'll just write the identity function. It's always fun when things change underneath me. F at this. Okay, that's changed. But in any case, what you have to be sort of aware that Python is comparing the string output from these functions. Something's just changed, so maybe I have to update these slides, but there is some relevant things. So it used to be the case that list had standard output. I hope that's still the case. Am I lying about this? Oh no, this is what I mean. Yeah, right. See, if I put in the empty string, it prints as this. If I give it a list, right, and I do stuff like that, it prints like that. Okay. So you have to be careful to match the string output of Python when writing these doc tests. It's not comparing a value. It's comparing the string output, right? So if I write the identity function, which is just a function that returns anything that you give it, and you give it the empty list, and you have a doc test saying the identity at empty list returns bracket space bracket, it will fail because the string doesn't output. The same thing goes true for lists. If you have a list, Python actually puts tailing space after every comma. So if in your doc test, you have to account for that. So this are going to fail for a variety of reasons. Be careful with tailing space. If you write empty list and then a space, it's going to say, well, that's not equal. List is not equal to list with the tailing space. This one is going to fail because there's no, it's not comma space, right? So you really have to ensure that you're matching string output perfectly here. Okay, so we're doing string testing, comparing printed output, and not equality testing, comparing values. Because this is sort of like a baby testing apparatus. We're going to give you the full-fledged one soon. the output must match what Python outputs exactly, right? So these would be the appropriate test for that. There's some other nuances here, like sometimes if you print a float, you have to ensure that you have the decimals there, so that's going to fail because that's expecting 1.0. The reasons that we don't test with floats is because floats are sort of never equal to one another. When we're doing float testing, we're basically saying, are these two outcomes close enough, right? Are these two floats, if we subtract them, is their absolute value less than some tolerance that we've kind of set? So that's why we're not going to deal with floats. Okay, so you can think about this one at home. So here's the power function. I programmed it with one line in the functional style. It does work. I'm trying to obscure its meaning from you on purpose, right? So this is like black box testing. So this is sort of like, if I gave you this and you didn't know that it worked, and my claim was that I'm giving you the power function, like what should the test coverage look like in this case? And I'm sort of saying, okay, it should be, you should test 0 to the power of 0, maybe 1 to the power of 0, 0 to the power of 1, 3 to the power of 1, 1 to the power of 3, and 6 to the power of 10, something like that. The more arguments that you introduce, the sort of like, you have to have like multiplicatively more tests, right? Because you have to set both of them to 0, one of them to 0, the second one to 0, right? So these number of tests you want is a lot of them up to the point you're adding redundant tests. That becomes bad. So here's one that you can do at home, right? Doc test for the following function, then implement it, return the larger of x and y. There are some edges that are going to be induced here. Sets are really obnoxious in Python because they print in random order. You never know what you're going to get when printing with a set. So for example, if ABC gets printed out as CBA and BCA gets printed out as CBA, and we have no idea why. It has to do with how it gets stored in memory. So you can sort of hack this into your doc strings, right? I can say, oh, the outcome of identity, if you give it the set 1, 2, 3, should be equal to the set 1, 2, 3, and what the outcome of that computation should be true, right? So this is sort of how you can hack these things into your doc tests so that the doc tester will work in this case. Because the other things we have are dictionaries, and I said dictionaries aren't ordered, right? So you may want to sort of validate that the dictionary coming out of a function is correct, and you just do it by the same way. Instead of saying, oh, when you give this function this input, it'll return this output, I'll say, when you give this function this input, it should be equal to this thing, which should indicate to you true in the test. You can use as many lines in a doc string as you want. These sort of triple chevrons indicate working in the REPL, so you can go ahead and define variables and utilize them. This is a really great example. You guys have all taken calculus, right? You know what a parabola is? If you probably know how to find what the lowest point on a parabola is by like finding its critical point and seeing where it's 0. So write a function which determines the lowest point on a parabola and write test coverage for this. You're going to induce a lot of edge cases. What if A is 0? Oh, crap, now that's a line. What if A and B are 0? Oh, crap, now that's the constant function, right? So there's a lot of things that you're going to, this is way less innocent than it seems at first glance. So try to see what kind of testing coverage you can get out of this. There's an answer made. Oh, so this is the tolerance I'm telling you about because you're going to get a float answer out of this. So I'm saying, okay, look, this is 0.001. If the output from this minus the thing I expect is less than 0.001, that's close enough. Okay. Finally, if you can just take if your doc string is getting quite large, you can just take the doc string out, exclude the triple quotes on the top and bottom, throw that in a file, and then you can actually test on that file using test file, right? So you can say doctest.test file. Here's the file with that giant doc string in it, and give me output. And finally, assertions. I just want to finish with this. This is becoming more and more popular. I think Lex Friedman just had a big podcast about like using assertions in functions. I use assertions all the time when I was working for Maple, which is loosely stands for math programming language. I was from mathematical computation. In mathematical computation, we know at certain points that there should be certain things that are true about the things that we're computing with. And we can actually embed those truth assertions into the code themselves, so we're alerted to something going wrong. For example, here's the factorial function. Factorial should never return anything less than 0, right? So at that point at line 5, if answer has to be greater than 0. So I'm asserting that this has to be greater than 0. And if it's not, Python will say you have an assertion error, and it will tell you exactly which line that assertion error has been triggered. So this will really help with code correctness. Another way that I loved utilizing this was, I told you I like short circuiting from if statements or loops using the return. The peril here is that if one of these returns don't trigger, the function is going to return none. And that is a very hard bug to track down. So normally when I short circuit out of a function like this, I make the last line of the function assert false. That means to say, if you arrived at this point, that should have never happened, right? So this insulates me from having an error where the short circuit has failed, and it's called a silent failure because it's going to return none. Things are just going to look screwy. Here are some exercises that you can do at home. Just look through them. It's good to try to practice with these type of things. So in summary, we can verify our duck string examples using duck tests. Tests should have sufficient coverage and not be redundant. Testing cannot and do not guarantee a function is working generally, but rather give confidence that a function is working. It helps you prevent coding errors. Thus concludes the imperative programming module. I will see you guys at week 13 and 12 or 11 and 12. I'll see you guys next week when I hand over to Casro, but thank you for joining me for the imperative programming module. I'll see you guys in a bit. I'll save your applause for the last lecture or your CCATs. Come get your ducks if you've seen them. If you want to check out the shirt, you're quite welcome to as well. All right.